screen?
Yes.
Yes. So yesterday we have discussed calling component and call component. Yes. And when a calling component is missing, we replace them with a driver. Yes. And if a called component missing, then we replace them with a stub.
Okay.
So let's carry on discussing further component testing strategy. So today we will discuss exactly the same thing. So we have some components in here. Yes, it won't be looking good, but still okay. So this is component is calling this component. This component is calling this component. Yes.
Yes.
This component is calling this component. This component is calling this. So we can name them A, B, C, D. Okay. This component is also calling this component. This component is also calling this component. This component is calling this component. Yes. I should have used more space because I have enough. So this is, you can say A, yes, B, C, D, E, F, like this, F, G, H, I, whatever it is. Yes, we can name it. So when we are testing, and when we test these components and when we integrate them, yes, so A is integrated with B, B is integrated with E, A is integrated with C, C is integrated with F. Yes. Now if we go this line, this is the sequence, this is the integration. If A is missing, okay, then we cannot stop testing, we have to carry on testing. So this is a missing component, we can call it. If this is missing, then we will replace with a driver. Yes. Understood? Now A is fine, it is there. So we are testing A, C and F. Yes. A, C and F. So if F is missing, then we will replace this with a stub. So you need to go integration of 2 places only, not all these 3 places. As for example, A is available, D is missing. Okay. A is missing, then you go from A to D. A is called calling component, D is called called component, and D is missing, so we will replace with a stub. Yes. Any question?
What is the stub?
Stub is a skeleton module, or you can say a substitute if you want to understand. So if I want to explain in a detail, that we have a code for component A. Yes. Code for component A, code for component B, and code for component C. Yes. So this A is doing something, some function there. Yeah, some function. Exactly for B, some function is there. Yes. And for C, some function is there. Now you want to test this, integrate these all and test it. So you are testing some, and it won't be that much end to end, but you can understand end to end scenario for component integration. Yes. Now if C is missing, then what happens? You can test A, you can test B, but what happens? You can't test it C. So you need to have a placeholder for C, so you can test everything together, an end-to-end component scenario. If A is missing, because A is called a calling component, then you replace, you need to have a placeholder. You can understand that way, and this is called a driver. If C is missing, they both are available. If C is missing, this is called called component, and you use a placeholder. It's called stub. So we can test end-to-end scenario, integrate these modules, these all units or components, and complete our testing activity.
Okay.
Any other question?
No, it's okay.
Okay. So in component integration, here we have say what, let's discuss the integration overall. Yes, integration testing. So here we are integrating component A with component B. Yes, exactly the same way you can have component B with component C. Yes, exactly the same way you can have component C to component D. Agree? Now if you have two systems, you won't be able to do independently with one system. If it is trivial, then you can do it. So in the same manner, you can integrate system A with system B. Yes, so system 1 with system 2. As for example, your software is built using so many different softwares. Yes, as for example, you go to the NetWest website. Yes, yesterday we discussed. So whatever you can see is the UI, that is system A. All the data, whatever you are seeing, that they are not stored there. Most of the things, it is coming from the database. Yes, so it is integrated definitely with databases. So that is system B, you can say. So what different integration you can have? So you can have DBMS. First thing you should have. Yes, that is database management system. DBMS means database management system. Any databases you are using, Oracle, SQL, MySQL, yes, Cassandra, Postgre, so many different database systems are there. So when you are using them, you can say database management system. Any data, okay, you can see they are stored in the database management system. Yes, then you have hardware environment. Yes, hardware environment can be two, for the server and for the PC. Your RAM, your hard disk, everything is there. Yes, they are all part of your hardware environment. Whatever configuration you have for the servers and any PC, they are all part of hardware. Yes, in the same manner, this hardware works on the software. Yes, so you have software environment. If you are using Mac, then you have Mac operating system. It is software environment. Yes,
Yes.
if we are using Linux, then Linux. If you are using Windows, then Windows running is Windows operating system, any other PC. Yes, so that is known as software environment. Then you have application software. What is application software? The programming language or any other software you use to build your application. Yes, just don't consider about the UI. Literally any system, any programming language or any tools we are using to build our system, they are known as application programming software. So if you go, for example, any of the website, okay, then if you click there, you can see if it comes .NET in the end, then you can say it is .NET. Yes, it is coming so big. So if you click in here, you will have the end point there, and you can say how the system has been built. That is known as application programming. If you are using Java to manage the databases and code, then that will be part of your application programming, application software. Any question?
No.
Okay, let's move to the next thing. Again, in the integration testing, what are the integration? Okay, when can we start integration testing and when can we stop it? Yes.
This is level of testing.
Yes, level. The first one was component testing. Yes.
Yeah.
First level is component testing. The second one is integration testing. So this second level is integration. So this is part of integration, and this is also integration testing.
Yeah.
Yes.
Okay.
So what are the characteristics we have for the integration testing and what you need to have? So what could be the test basis for integration testing? Yes. Software and system design. Yes. In software and system design, it clearly discussed or indicated that how the systems or the units will be integrated. How one system is passing data to another system. It is in detail, okay?
Okay.
Clearly mentioned. So you need to go to the system design, and if you want to go to the system design, you just Google system design. Okay, I'm just showing you the image. So this is the system design. How this is system design is topics, short, medium, and everything is there. Yes, how they are passing the data. This looks good. This is might be PC or server, you can say. Yeah, PC. It is sending some data to somewhere. This is this circle, their database management system, you can say. Looks like email is PC. One PC is sending an email and another PC is receiving. Yes. If you go to another image, then you will be able to see details. Forward proxy internet. So this is called system design. This is good. They explain, see, module building, development. I can't see that much clearly, so you won't be able to see it, but you will have a structure in the design how these systems or modules will be integrated. Yes. Any question?
No. Thank you.
So design. The next, architecture. How the system will be built in the same manner the design and architecture will have this. This is also architecture, whatever I showed you here. Workflows. If you are processing something, some functionalities is there. So you are doing some work from where the flows goes. So if you go to again the design, you will have the workflows. So from here it goes here and that goes here. Yes. That is the flow. You can see in here J2 developer, it is receiving and sending data to external model libraries. Or if you go to J2 builder, it goes to J2 universal framework, then it goes to SQL database, and there is no but from J2 universe framework it goes to J2 visual. So it is a flow from one place to it goes to another flow for and your functionalities or any business process. Yes. So you can have workflow, so you can see it and test it. Use cases. You need to have use cases. What is use case? Use case is a requirement only, but written in a way that an actor communicates with the system. So you can say the transaction between an actor and the system, if it is stated in the transaction format, this becomes a use case. Yes, the transaction between an actor and the system, or any requirement indicating the transactions between an actor and the system, will be an use case. Yes, who can be an actor? You can be an actor. Yes, so let's go and write an use case. Yes, so here you are there as an actor. Okay, and you are dealing with one system. The system will be, I'm just saying it is ATM management system. Okay, yes, ATM management system, ATM management system. Yes, so what you do with this ATM management system? As an actor, you are inserting your card. Yes, actor or the user, you can say user would be good. Actor or user inserts an ATM card. Yes, I just use ATM card. It could be debit card or anything. What the system does, as soon as you insert a card, does that ATM do anything? Yes, what it does, verifies the card. Yes, am I right? Then what the system asks, as soon as the system asks, verifies the card, the system will ask, I will just say system. Okay, system will ask for the PIN. Yes, am I right? Are you there? Hello?
Hello?
Yeah, are you there?
Yeah.
Okay, so the system will ask for the PIN. Yes,
Yes.
and you enter the PIN, random PIN. Yes,
Okay.
what the system will do, this actor enters the PIN. So let me actor enters the PIN, actor or the user enters the PIN. Now what the system does, you have used your ATM card. Yes,
Yes.
what is the next step?
Receive the money.
No, system will authenticate or authenticates the PIN. Yes, am I right?
Yeah.
When the system authenticates, what it will do again, it will authenticate, then system will display the available option. Yes, any question?
No.
And the user selects, or the actor selects one of the options. Yes, I'm not going so much details. It should not be one of the options. When you write the use case, it should be specific one thing. In testing this could, but as I'm explaining, so that's why. Then user selected the option. If it is user selects withdraw money option, withdraw
Money option.
money option, then what happened? What system does? Yes,
Yeah.
you can say I want to withdraw money, then the system will display how much 10, 20, 30, 40 available options. What are the available options the ATM system will have? Okay, it has to be specific. And what happens? What does the user do? One of the options, 20 pound. Then what the system does? Yes,
Yeah.
system authorizes this. Yes,
Yes.
direct. If you might not have money, then what happens? If you want to withdraw 200, but your bank has only 20 pound, 5 pound meter balance, not meter balance, bank balance. So it authorizes it. It is done. Whatever options you selected. Yes.
Yeah.
Authorize the option. Then what happens? Dispense the money. Yes.
Yes.
System dispense the money. But before the system dispense money, there is an option there. You want the paying in slip. Yes.
Yeah.
This is just let me write. Okay.
Yes. Yeah.
Dispense the option. Then what happens? User collects the money. Yes. And what happens after? If you have selected this, and the ATM will, what it will do? Dispense the card. If any requirement is written in this format, a transaction between an actor and the system, it will be known as
Integrated.
yes, use case. It will be known as use case.
Okay.
The next one is sequence diagram. You need to have, for integration testing, you need to have sequence diagram.
Okay.
What is sequence diagram? The photos I showed, they are also part of sequence diagram. Okay, from one place to it goes to another one. This is the best sequence example of sequence diagram. System design process, this is the best. So from here it has this sequence and it has this sequence.
Yeah.
Visual Studio mostly used to write the sequence diagram for the process flows. So you have the processes for any business process. Business. So these processes are given, explained in a sequence diagram from one place or from one process how it goes to another process. Yes. What are the test objects for integration testing? Objects for integration testing. What could be? System or subsystem or databases. Yes.
Okay.
Databases, because from databases only we derive the data. So database, subsystems. Yes. Because you are integrating the systems, so you are testing them. The database integrated, and you are testing the database. Infrastructure, the structure of the application. Yes, you need to have it, although you are testing the infrastructure. As for example, in the process flow, you say that from one place the other place some data is sent. If it is not received the data, then you can say there is an infrastructure failure. But you don't go this much in detail in the tester. You directly say something this didn't work, so the developers will investigate. Yes.
Yeah.
Interfaces. Interfaces means communication, interaction between one system to another system. So you are testing system A is independently working fine. Yes.
Yeah.
System B is independently working fine. But what happens when you integrate system A with system B? Yes. And you are testing is API, application programming interface. So when you integrate one system with another system, how you are fetching the data and receiving the data. That is known as application programming interface. Any question?
No.
Let's again discuss the strategy. Integration strategy. Integration test strategy. Again the same thing, yeah. So the test interactions between software components, it is known as integration testing. But can you do this testing everything together? No. So you have to have some strategies. So there can be two kind of strategy. One, incremental strategy. Yes. And another is big bang strategy. So let's go to the paint again and I'll explain you.
Okay.
So now you have this component. Let me put bigger one using some space, not like last time. Yes.
Yeah.
So you can see this component is integrated with these components. Yes. So you can say this is A, this is B, C, whatever it is. Okay, I'm not bothered about this. So these components are integrated. When these components are integrated, if you want to test this sequence to this sequence.
Yes.
Okay, so component A, let me write. Component B, component C, component D, component E, F, G. I just randomly name, yeah.
Yeah, no.
So when A is integrated with B, B is integrated with C, A is integrated with D, D is integrated with E, and here F, G as well, yes. So there is a way of testing this sequence. One big bang. You integrate everything together and test it. Yes.
Okay.
And incremental means you can integrate like A with B, B with C, A with B, B with E, A with D, D with E, A with D, D with G. Yes.
Yeah.
So that is called incremental. If all these are bunched together and you test it, it becomes big bang. And if you go in the sequence, like as I say, A, D, E, A, D, G, A, F, G, A, F, H. Yes.
Yeah.
And if you test it, that is known as incremental. In incremental, there are three types. Okay.
Vijay sir,
Yes.
are we going incremental or big bang strategy? Both provide results same or different?
The result, it's a good question. Our intention is to find out defect when we integrate two components or two systems together.
Okay.
So the end result is same, but there is an issue. Okay. I explain you one by one. So when I explain, you will have the answer. So in incremental, you will have top down, bottom up, and functional tasks. Okay. So what happens in here? When you integrate with A, with B, with C, yes. So your concentration is bit less, yes.
Okay.
Only few things are there and few things are testing. So even though your intention is to find the defects, you exactly verify what defects would be.
Okay.
What is causing an issue and what is the failure, yes. If you integrate with A, B, C, and if you start testing from C, You test C first, then B first, and then A. That becomes bottom-up approach.
Okay.
Yes. When you are integrating A, B, and C, and you are testing the functionality when you integrate these three components, that would be a functional task. But now you have integrated all this and you are executing test cases. Then what happens? It becomes very complicated to identify what integration is causing an issue.
Okay.
Yes.
Yeah.
It becomes very difficult. It failed something, but what failed? Yes. You don't know. It failed something, but what failed is a question. And that's why this big bang integration testing should be avoided, because everything is linked together. And when everything is linked together, it becomes very complicated, very difficult to isolate a defect. It takes more time to investigate. Because if this integration is fine, yes, then you just disregard, okay, this is fine. Then you are integrating this one, this pass. You are integrating this scenario, this pass. You are integrating this and testing, okay, it failed. Then you know these two passed, these two area passed, yes, and this failed. So it becomes easy to identify defect, isolate it, and fix it. But what if you are integrated together and something fails? So you need to say, is there an issue between A and B, B and C, B and E, A to D, D to E, D to G, A to F, F to G, F to H? Yes? Something like this.
Yeah.
But one by one, it reduces your workload as well, because you know what you are doing and it becomes easy. The last is big bang. Discuss, yes. This big bang should be avoided because all the modules or components are integrated together and it becomes very complicated to isolate a defect when we use big bang approach. Yes?
Yeah.
In here, what kind of typical defects you can find? Defects and failures for component integration testing like include incorrect data, if any data is missing. Yes, missing data or incorrect data encoding. When we receive the data from one system to another system and it fails, we can find out defects like this. Incorrect sequencing or timing of interface calls. What time component A is calling component B and component B is responding. Yeah. Interface mismatch. When we match those two components, what is the issue? They are mismatching. Yes. Failures in communication between components. These components, they are not communicating with one another or each other. Yes. Unhandled or improperly handled communication failures between components. They are communicating, but this is not properly handled. Incorrect assumptions about the meaning or units or boundaries of the data being passed between components. So when one component is passing the other data, there can be anything. The boundaries might be incorrect, yes, or we might have incorrect meaning, and that's why the integration testing fails and we identify issues. Any question with this?
If integration is failed, so why we have to do integration testing?
Because the whole system is built integrating the components and integrating the systems. Yes.
Oh yeah.
So we have to verify the system A is working perfectly fine. But when we integrate, as for example, I have a database in here. I don't have it. Might be in a different PC, might be. Okay. So this is one of the tools I have for testing. This database is working fine. But what if when I integrate this database with another system, it is causing an issue and it is not sending any data? Whatever you receive on the UI stuff, okay, when you check the bank balance, that is coming from the database. So if the database is not properly responding to your request, then there is an integration issue. An integration issue, the system will fail, and if the system will fail, we have to go back again why testing is required. Yes?
Yeah.
That's why we need to do proper testing and verify each and everything is working correctly.
Okay.
Any other question?
No, thank you.
Okay, let's next move to system testing. So what is system testing? The whole system, overall system becomes a system, yes?
Yeah.
When you test one unique independent system, that becomes a system testing. So what is system testing? The process of testing a system to verify that it meets specified requirements. What is the definition? The process of testing a system to verify that it meets specified requirements. Yes?
Yeah.
What could be the test basis for system testing? Yes, test basis for system testing. The system itself, yes? Am I right? And software requirements specification. How you are going to build the software or the system? That is called software requirement specification. Use cases will be there for literally everything I have explained you. So go to the models and state diagrams. Yes, we have discussed these models and diagrams, how the system would be built in the model format and diagram format. Yes.
Yeah.
Risk analysis report. When you build the whole system or the software, what would be the risks? Yes. What would be the probability of failing the system? What would be the probability of an adverse event occurring? We have to have the list, and that is your test basis. Based on that, we will design our test cases and test the system. There should be two different risks, one for standalone system and web-based systems. You must be knowing this one. Standalone system and web-based system. Yes. What is standalone system? It is not now, but I can give you an example of Microsoft product like Word and Excel, PowerPoint. You install it and launch from your PC locally. Yes?
Yeah.
A standalone system. But nowadays they are web-based as well, because you can just access through the website. Whatever is on the web, and if you are accessing, that will be web-based systems. Yes. As for example, your NetWest system is a web-based system. Now I am asking you one question. What would be the different risks we will face for the standalone system and web-based systems? Just give one example of web-based system, it would be good. If you do internet banking, what would be the risks you will have?
Stalling money.
Yes, that is security.
Yeah.
Somebody can steal money. Hacking. Yes,
Yeah.
that is one of the biggest threat we have for the web-based systems. Standalone system, if the personal computer PC, you can call it, if the system crashes, then you will lose the data.
Yeah.
Nothing would be recovered. Yes.
Okay.
Epic user stories. Next one is epic user stories. What is epic?
Big.
if you go, you know that Rama and Mahabharata, they are called epic. Epic is a big story, you can say, simple way if you understand. High level requirement you have, then you can say that is an epics. From that epics you can have multiple user stories. So one specific requirement broken down and written in given when then format, then it becomes user stories. Yes.
Yeah.
Epics can be high level, like you know that it can have multiple stories together, user stories.
Okay.
System and the user manual. System and user manuals. In the user manuals we have defined how the system can be used. Yes, that's why the user manuals, they are the test basis for system testing. Sometimes from the manuals we will test the whole system. What are the test objects for system testing? Application. Yes.
Yeah.
Or the application. Operating system. On what operating system that application will run? Yes. Or systems. Does it support only Windows or Linux or Mac OS? They're all operating systems. Yes. So when you are testing this NetWest application, you can test this one in a different way. Yes, let's go. Are you able to give any examples? What are the different scenarios you have to test the whole thing high level?
No.
Cross browser. I'm using Chrome, so it should be tested on Chrome. Somebody is using Internet Explorer, so it should be tested in Internet Explorer. Yes.
Yeah.
You can think how big it would be. Somebody is using Safari, then Safari. Somebody is using Opera, and then it should be tested on Opera. Somebody is using Edge, then it should be tested on Edge. Yes.
Yeah.
Think of any of the banking website. Now somebody is having Windows operating system, so it should be tested on Windows operating system. Yes.
Okay.
But somebody is using Linux, then you need to test this one in the Linux operating system on Linux operating. Somebody is using Mac, then MacBook means it should be tested on Mac operating. Somebody is using mobile, somebody using any mobile kind of device mean. Yes.
Yeah.
Then it should be mobile testing, you call it. Yes. System configuration. How the system configured, so that should be tested. Yes, that we are testing. And system under test means application itself. System under test, whatever we are testing, that is the system itself is a part and we are testing it. If it is 1, 2, then 2. As for example, NetWest website, then I gave you high level scenario, but the data is stored in one of the databases from somewhere. So the database, there is a part of applications we need to do database testing. And that database is stored somewhere in a server. Yes. And it is fetching data. So the APIs, application programming internet interface, we need to test. Yes. And what it tests, what is the main purpose of system testing? Anyway, finding defects would be there. Yes.
Yeah.
But here we are testing end-to-end behavior of the whole system or the product. Yes. What we are testing? Finding defects as an end-to-end behavior.
What is the end-to-end behavior?
Yes, what is end-to-end? End-to-end. So as for example, British Gas is supplying your energy. I'm giving you a different example now. Yeah, electricity. Here electricity. Now you called Eon and you want to move to Eon. Okay, so when Eon processes to British Gas to switch the transfer, whatever we call it, yes, and the whole process is complete. From British Gas you move to N Power. British Gas closes the account and account is open and everything is running in Eon. That whole process, whatever you are doing, that is end to end. Yes, I give you another example. You are logging out of the system. Okay. So log out is your process, but when you log in and log out, that is an end-to-end. Logging in, logging out, end-to-end scenario. Yes. Okay. The whole story, gas moving supply from one place is a very big. But when you start anything you are doing, as for example, you are checking the bank balance. Yes. Just checking the bank balance, it is one part of test case. But when you say end to end, you can withdraw the money, check the bank balance, you can deposit the money, check the bank balance. When you have end to end process for anything, that is called an end to end scenario. Yes, transferring money for you looks simple. Yes, go add the recipient and transfer them. But if you see it how it comes end to end, you log in into the system, one thing. Yes, you don't have the recipient, so you added the recipient, that is another thing. Am I right? You are transferring money someone, so you are selecting one of the amount, entering that amount data, and then clicking on the transfer, you are transferring. So there are more than, but I can literally say there are 4 things we count for. We bunch together for transferring money, log in into the system, add a recipient, select the amount and transfer. That is an end-to-end scenario. Okay. Yes?
Yeah.
What could be the test environments for system testing? Can you tell me? I have explained you already. The test environment would be exactly the same. Database management system. Yes, databases. What else? You will have the hardware. Yes, you have the software environment. Am I right? What else? Application software you will have. Yes, exactly the same. They are the test environments for system. What are the objectives of system testing? Can you tell any objectives of system testing? Any? You can exactly say finding defects.
Yeah.
Testing, our main intention is to find the defects, so you can say finding defects. Yeah. Yes. What else? Reduce risks. Yes, because you are testing overall as a system. If you identify defects, you raise it and you fix it, means the developer fix it, you retest it, regression testing is done, so as a result risk is reduced. Yes.
Yeah.
You are also testing functional and non-functional behavior of the application. Of the system. Functional means the functionalities. 2 plus 2 equal to 4. That calculation is a function. Yes. When you say you transfer the money, you add a recipient. Yes. You log in into the system, you log out of the system, anything, this is all called functional requirement, because they have some functions to do. Am I right?
Yeah.
What are the non-functional requirement? When you are dealing with any non-functional side of the requirements like security, performance, overall, if I say, they're all non-functional requirement. Stress testing you are doing, yes, they're all non-functional testing. Load testing, they're all non-functional testing. So when you are writing the requirements, you have to have the functional requirements and non-functional requirements. Non-functional requirements states how many users can log in into the system. Yes, that is non-functional. How much time the system will take to respond to your data, that is non-functional requirement. Yes.
Okay.
Validating the system is complete. Yes, and works as expected. That is also purpose of the system. Yes, you need to verify literally everything, validate the system is complete. It does not have any issue. It will have anyway, but the main purpose is to verify it, validate it, and then it works as per expectation.
Okay.
It has also one objective is to prevent defects. Prevent defects from escaping to higher level. Yes. How higher levels? I say you have tested component testing, you have tested the integration, but their requirements are different. So sometimes we might have missed some of the bugs there. Yes. And when we do system testing, we are going to prevent them, so we are not going to miss these kind of defects, and that's why we are doing system testing, testing the system overall as a whole. That is the system testing, and the purpose is to prevent the defects. Any question?
No.
Okay, let's go to the functional and non-functional requirement of system. Yes, functional and non-functional requirements of the systems. Yes.
Okay.
These are based on risks. Yes. What risk the application will face. Another based on the test cases. Okay, functional and non-functional testing based on
Risk.
Testing based on risks. What risk the application have. Functional and non-functional requirements. Yes, functional and non-functional requirements. So your test cases will be derived from these requirements, functional requirements and non-functional requirements. Functional requirements means the performance, the behavior it does, and non-functional like the performance related. So we have these requirements. Based on that, we will do functional and non-functional tests. Business processes. We will have business processes. Yes. If you go to the bank, you will have money related processes from one to another, something like this. And as for example, I gave you the energy supplier example. Then they are dealing with gas and electricity. So you can switch account, meter can be removed, meter can be installed, meter can be extended. Yes.
Yes.
These are the simple things, but it has so many different things. These meter operators, they manage the data. No, not data, meters.
Okay.
Data collectors, they collect the data. Okay.
Yeah.
Data aggregator, they store the data. DC, they store the data. Everyone stores the data, but their intention is for different. Yes. Data collector is settles the accounts with suppliers and national grid. So many different business. So they will have different processes. So that one of the business process you have, that would be the basis from where you will derive the test cases for system testing. And they can be functional or non-functional. Use cases and scenarios, you know that, yes? Use cases and scenarios. Use cases and scenarios, you know, models. The models of the application, how the structure and how it will be, the application has been built. That is the model. Yes. It can be functional, non-functional. Based on that, you will write test cases and you will do system testing for both functional and non-functional side. This system testing is done by an independent test team. Okay, system testing is done by independent test team. So you have a separate team doing this system testing. Any question?
Function, non-function testing depends